This is the solution to puzzle 27. Alice and Bob take 2 hours to dig a hole. Bob and Chris take 3 hours. Chris and Alice take 4 hours. How long would they take working together? So let's denote by A the rate at which Alice digs a hole, measured in holes per hour. So if A is 2, Alice digs 2 holes per hour. If A is 1/2, she digs half a hole in 1 hour. So in 1 hour, Alice digs A holes. Whatever this number A is, we will have to find it. In 2 hours, Alice digs 2A holes. Let B be the rate at which Bob digs a hole. In 1 hour, Bob digs B holes. In 2 hours, Bob digs 2B holes. So let's put these two things together. In 2 hours, Alice and Bob, working together, dig 2A plus 2B holes. And we are told that Alice and Bob, if they work together for 2 hours, they dig 1 hole. So 2A plus 2B is equal to 1. Let C be the rate at which Chris digs a hole. Working as before, we find 3B plus 3C equals 1, because Bob and Chris working together take 3 hours to dig a hole. 4A plus 4C is equal to 1, because Alice and Chris working together take 4 hours to dig a hole. So we now have 3 unknowns, A, B, and C, and we have 3 equations. To find A, B, and C, we need to solve this linear system. And this system is really easy to solve and can be solved in many different ways. But let's solve it here using Gaussian elimination, which we will discuss in semester 1 in Introduction to Linear Algebra. So we might as well make a start on it now. Gaussian elimination says the first thing you need to do is look at this term up here at the top left and make its coefficient equal to 1. So in our case, it's 2, so divide the first equation by 2. The first equation becomes A plus B equals 1/2, and we leave the second equation and the third equation the same. The next step in Gaussian elimination is to kill this term. Well, that's already not there. It has coefficient 0 in front of it. And this term. So to kill this term, we can multiply the first equation by 4 and then subtract the first equation from the last equation. So that will be 4A, and when we subtract, that term will be 0. So if we do that, we get the last equation becomes 0 times A, so that's not really there, minus 4B plus 4C equals -1, and everything else stays the same. Again, this system is really easy to solve in many ways. For example, if we look at this 2x2 piece, that just has B and C as unknowns, it can be solved very easily. But let's continue with Gaussian elimination. The next step is to make this coefficient here, the coefficient of this term, equal to 1. So divide by 3, the second equation, we get B plus C equals 1/3. Leave everything else the same. The next step is to kill this term. And to do that, we can add to the third equation 4 times the second equation. 4B will cancel out this term, 4C will combine with that to give 8C, and everything else stays the same. Now that's our final system, and that system solves itself. Let's rewrite it by removing all the terms that have coefficient 0. Here's what it looks like. From the last equation, we can find C. C is 1/24. And once we have that, we can go back to the second equation, substitute the value of C, and solve for B. And once we have B, we can go back to the first equation, substitute the value of B, and solve for A. This is known as backward substitution. Here's the solution. A is 5/24, B is 7/24, C is 1/24, And remember, that's holes per hour. So if all three work together for 1 hour, they will dig the sum of these fractions, 5/24 plus 7/24 plus 1/24. That's 13/24 holes in 1 hour. So to dig one hole, they have to work 24/13 hours.